Welcome to the Lionheart Academy. My name is Richard Tai. Today we're continuing our trigonometry lessons. Today is lesson number 16. Today what we're going to talk about is the reference angles and trigonometry functions. Now I think you probably remember several lessons ago we talked about what is a reference angle, how to find the reference angle. And today let's go ahead and take a look at how reference angle would help us, because I did mention at that time reference angle are useful. So this is the time when we are really able to make reference angle of use. So what happens is that well, throughout the development of trigonometry, okay, in the past we don't have calculators like we do have today. So it's very hard when you want to calculate the angles or trig functions of an angle. It's hard to remember everything. You want to memorize everything, it's going to be difficult. It's much easier just to memorize the most important quadrant, which is quadrant 1. Quadrant 1 is the most important quadrant. And if we can relate everything back to what they are in quadrant 1, then it's much easier for us to understand them and for us to analyze them. So even though nowadays we have calculators and you can very easily just type in whatever angles you want to measure, you can just type them in the calculator, but still reference angle is very powerful because it will allow us to do things mentally. Now, as you may know this and you may not know, if you're comfortable with mental math, if you're comfortable with doing things in your heart, in your mind, without the aid of a calculator, without the aid of writing things down, it will make things a lot easier, it will make things a lot faster, also more efficient. So it is one of the point is when you do reference angles, well, when we do reference angle, we're counting you to use your mental ability to relate every angle from quadrant 2, 3, and 4 back to an angle in quadrant 1. And quadrant 1 will be very familiar to us. So that's why it will increase our efficiencies and it will improve your confidence in knowing these things as well, because you can know them by heart. Alright, so let's take a look at what reference angles in trigonometry is about. Now remember, reference angle, we used to call them theta prime, right? So in quadrant 1, let's review what they are. In theta prime, the reference angle is just equal to itself. Okay, and in second quadrant, the reference angle, again, reference angle is the angle formed, the acute angle formed between the closest x-axis. Okay, so it's this angle in this case, this angle is the reference angle for this angle in second quadrant. If the terminal side is right here, this is the reference angle. So this reference angle will be 180 degrees minus theta. I'm going to use in degrees right now. It also means pi minus theta. But those are interchangeable. I can use 180 degrees minus theta, or I can use pi minus theta. Now again, the reference angle is an acute angle formed between the closest x-axis and the terminal side. So here it's going to be theta minus 180 degrees, or theta minus pi. So theta prime is going to be like that. And then lastly in quadrant 4, this is the angle. It's going to be theta prime is going to be 360 degrees minus theta. Alright, so let's suppose they all have the same x coordinates. Okay, so here let's look at this x coordinate, x and y. That's positive, both of them are positive, that's not a problem. Okay. Now suppose the distance is the same but the direction is opposite, so in second quadrant this would be a negative x and the same y coordinate, because the y coordinate, this is y, right? But this one becomes a negative x coordinate. So if you're going from origin over in the left-hand direction, it's negative. Okay, now going down here, however, both of them will be negative, so x becomes negative and y also becomes negative. And in quadrant 4, the point on the terminal side would be a positive x and negative y. Now we also suppose that they all have the same radius. Now remember, radius is always positive, so we're not going to have any different change. So r is always the same. So based on this information, I know it's a lot of information here, but based on this information, we can understand the in different quadrant how things will change, how the angle will change. Okay, so basically, if you are in quadrant 1, If you're in quadrant 1, nothing is going to change. So sine of theta is just equal to y over r, which is the same. Okay, cosine of theta prime, okay, is just going to be equal to x over r. The reason is in quadrant 1, theta prime, the reference angle, just equal to theta. So they are the same angle. So your angle is the reference angle to itself. Okay, y over x. Okay, so secant theta will be r over x, and cosecant theta will be r over y. So we need to remind ourselves this definition all the time. Just need to get them into our hearts so that we can do them more conveniently. We can do them more confidently. You don't have to worry about too much. Okay. All right. What about in quadrant 2? So let's move up a little bit. Okay. In quadrant 2, your reference angle is going to be 180 degrees minus theta, right? So that's why your reference angle is basically the same as theta, but not quite, is it? Your reference angle here, because it has a negative x value, and your y value remains the same. So if I do sine of the reference angle theta prime, which is 180 degrees minus theta, okay, it will be equal to the same as y over r, because we do have the same radius and y remains the same. So that means sine of 180 degrees minus theta is the same as sine of theta. So this is going to be a very valuable reduction method, formulas for us to reduce, for us to simplify things. But what about cosine of 180 degrees minus theta, cosine of the reference angle in second quadrant? Well, the x value changed to a negative x over r. So this becomes a negative cosine of the original theta. Okay, so let's say theta is 35 degrees in second degree, excuse me, in second quadrant is 180 degrees minus 35 degrees. Okay, but we'll do examples like that. So cosine of 180 degrees minus 35 degrees will be equal to a negative cosine of 35 degrees. The reason is 135 is in, or 180 minus 35, which was 145 degrees. That would be in second quadrant. So we can relate the angle in second quadrant back to an angle in first quadrant. However, the sign has to change due to the changing in the different quadrants. Now what about tangent? Now tangent is y over x. However, x becomes negative, so it also becomes, the whole thing also becomes negative. Okay? Alright, let me keep writing. So what about secant? Secant of the reference angle in second quadrant, well, secant is r over x, but x changed to negative, so this will also become negative secant theta. Cosecant of 180 degrees minus theta will be equal to r divided by y, but y remains positive, so it's the same as cosecant of theta. Alright, and lastly, cotangent of 180 degrees minus theta will be equal to x over y, so it would be negative cotangent of theta. Now if you look at this, you should remember something. Remember our acronym ASTC? Right? Remember our acronym? Let me go ahead and put back our acronym here again. Remember our acronym? All student takes calculus, right? ASTC in each quadrant. And as you can see, in the second quadrant, only sine is positive. Sine and its reciprocal is positive. Look at that. In the second quadrant, only sine and cosecant remains positive. Everything else becomes opposite of what they were in this first quadrant. So this is this is consistent with what we have talked about before. You got to remember that. Okay. Now I'm going to give you some practice tonight. Okay. So there are some practice problems you can go ahead and take a look at to test to see if you really understand this. Alright, in quadrant 3, let's go on to quadrant 3 and take a look at. In quadrant 3, you have the angle, so the reference angle is equal to theta minus 180 degrees. Okay, theta minus 180 degrees. Actually, I made a mistake here. It's theta plus 180 degrees. I'm sorry, theta plus 180. Yeah, it's 100 is theta. Theta prime is theta minus 180. No, actually, no, that's right. This is theta minus 180 degrees. That's not a problem. Okay, so it's theta minus 180 degrees. So it's theta minus 180 degrees. Okay. Now, but this is the angle in okay. Well, the reference angle is equal to theta minus 180 degrees. So if we look at the original angle related to theta here, the original theta is here, so we have to add 180 degrees to get to this particular angle. Okay, so let me go ahead and write it in such a way. So what we're doing is we're actually adding the original theta in 100 plus 180 degrees. Plus 180 degrees. The reason is where the original angle of theta is right here, right? So, and then the actual angle in third quadrant is 180 degrees more than the original angle of theta. So theta, this theta prime even is going to be theta minus 180. So theta, this angle theta will be equal to theta prime plus 180 degrees. Alright, I know there's a little bit confusion, but hopefully you'll be able to see that. Okay, this is the original theta, right? You add 180 degrees, you get to the angle in third quadrant. Alright, so now this time the negative y will become, because both x and y have negative exponents, negative values. I'm sorry, negative values. So this becomes negative sign of the original theta. Now this theta is the theta right over here. Okay, this theta is the theta in first quadrant. Alright, and cosine of theta plus 180 degrees. So 180 degrees plus theta, it will be a negative x over r. So it will be negative cosine of theta. Alright, I'm going to demonstrate this to you in a little bit. So let's go ahead and went through this one by one first. Alright, so this will be negative y divided by negative x. But negative y divided by negative is positive, so it becomes the same as tangent of theta. Okay, so in third quadrant, the tangent doesn't change. That's what it's telling us. The tangent value in third quadrant doesn't change, but everything else changes. Okay, r divided by x, so this will be negative secant cosecant theta plus 180 degrees will be r divided by negative y, so it's negative cosecant of theta. Okay, and cotangent of theta plus 180 degrees will be equal to negative x divided by negative y, so it becomes positive again, so it's become positive cotangent theta. So as you can see, in third quadrant t, right, only tangent and cotangent is positive, everything else is negative. Alright, lastly in quadrant 4. Now in quadrant 4, the reference angle is equal to 360 degrees minus theta, right? And this is the angle, is the correct angle here, so theta prime is equal to 360 degrees minus theta. Alright, so let's go ahead and write 360 degrees minus theta equal to, okay, well, in quadrant 4, y is negative, but x becomes positive, so sine remains negative sine theta here. Cosine of 360 degrees minus theta will be equal to x over r. So x becomes positive again in quadrant 4, so it's going to be the same cosine value. Now, however, tangent, because y becomes negative, right? So it's negative y over x, so it becomes a negative tangent of the theta in what theta would be, what the tangent would be in first quadrant. Okay. And secant of 360 degrees minus theta would be equal to r over x, so it's the same as secant theta. Okay, cosecant 360 degrees minus theta would be equal to r over negative y, so it's negative cosecant theta. And then cotangent of 360 degrees minus theta would be equal to r negative x over negative y, so it's negative cotangent theta. Alright, so after all this, do we have to memorize all of them? No, not really. You just have to understand the pattern. What's the pattern here? You don't have to memorize. The pattern is ASTC. All student takes calculus, or all students take calculus. So How student takes calculus. A, everybody is positive in quadrant 1. So if you look at quadrant 1, if you look at right here, the formula for quadrant 1 sine, everything is equal to itself, right? However, in quadrant 2, guess what? If you have angle in quadrant 2, it's related to the reference angle to its angles in quadrant 1, but the signs have changed. Well, how do you remember what's positive, what's negative? A, S, T, C. Okay? In quadrant 1, everybody's positive. In quadrant 2, only sine and its reciprocal cosecant is positive. In quadrant 3, only tangent and cotangent are positive. In quadrant 4, only cosine and sine is positive. Okay, so you don't have to. Yes, we're writing this down. We explain to you how everything becomes what they are, but we don't have to memorize it per se. Okay, but let me show you some examples. Okay, so let's say we have sine of 130 degrees. Okay, and we want to express this using its acute reference angle. Now, sine of 130 degrees is in second quadrant, right? Now, its reference angle is what? Okay, so the reference angle for 130. So the reference angle is 180 degrees minus 130 degrees is 50 degrees. So we know the reference angle is 50 degrees. So sine, but because in second quadrant sine is positive, so it's the same as sine of 50 degrees. Okay. And now, what about cosine of 130 degrees? Cosine of 130 degrees, because cosine in second quadrant is negative, so it's going to be equal to negative cosine of 50 degrees. What about tangent? Tangent 130 degrees. Now, tangent in second quadrant is also negative, so it's going to be equal to negative tangent 30 degrees. Okay, so does that sort of make sense? Let me show you another example here. What about, let's take a look at sine of 220 degrees. Okay, well, 220 degrees, let's see what's the reference angle for 220. So you can take 220 degrees minus 180 degrees, and that'll give us 40 degrees. So that means the reference angle for 220 is 40. Okay, so because that's another way we can write this. So sine of 220 is 180 plus 40. Right, so this is your reference angle there. That was what the formula was about. Is theta plus 180, or is 40 plus 180? But how do you get 40? You have to subtract the angle that you're working with minus 180, right? Minus 180 from that angle. So anyway, but in sine in third quadrant is negative, so it's negative sine of 40 degrees. All right, and cosine 130, no, not 130. I'm sorry, I was looking it up. 220 will be equal to negative cosine of 40 degrees, because cosine is also negative in quadrant 3. Then what about tangent of 220? Tangent of 220 will be positive tangent of 40 degrees. The reason is because they have the same sign. Tangent is positive in third quadrant. So of course, I didn't do secant, and secant in this case of 220 degrees would be a negative secant of 40 degrees. Okay, and then cosecant 220 would be also a negative cosecant of 40 degrees, and cotangent of 220 degrees would be a positive cotangent of 40 degrees, would be the same as cotangent. So this way we can relate anything back to the first quadrant, and this will help us greatly, and then give us a different method, a more efficient method to deal with the angles that we have. Okay, all right, so this is it about today's lessons. Oh, if you have any questions and comments, please post them online in the comment sections, and then I will be posting recommended practices and the links to the pages of this textbook. If you don't have access to this textbook, you might be able to search online. This is called Plane Trigonometry with tables. I'm using from Abeka Academy Abeka books, and some of you may be familiar with that, but they do have quite some practices for last lessons and for this lessons, and then hopefully you'll be able to work on those practices to help you get more familiarized with this concept. All right, hopefully we'll see you next lesson. Goodbye.